Hi everyone, we are Group 2. Today we want to present about slide around Terengganu, which will present about 3 places we go for our field trip. The places are Pantai Kemasik, Bukit Keluang, and Bukit Hulu Setiu. Before I start to introduce these 3 places, I will give a simple introduction about Terengganu. Terengganu is located in the eastern belt in peninsular Malaysia. The eastern belt has low grades of schist and most of the older sediments such as Carboniferous and Permian clastics, limestone, and volcanics, while Terengganu that is located in the eastern belt consists of the Carboniferous metasediment, igneous rocks, and Jurassic Cretaceous continental deposit. Then we will move to our next slide, which will introduce the 3 places we go for our field trip. First of all, Pantai Kemasik is a beach that is located in Kemaman district. Kemaman is the endmost district to the south of Terengganu. Pantai Kemasik has undergone a lot of tectonic activity. Thus, multi-phase deformation was formed there. Pantai Kemasik are composed by sedimentary rocks such as sandstone and mudstone, but some of them have undergone low-grade metamorphism process. The orthorhombic mineral was also formed in this area due to tectonic activity in ancient age. Besides, it is a tidal depositional environment. The second location, Bukit Keluang Formation, is located in Besut. It comprises interbedded reddish continental clastic sedimentary rocks such as conglomerate, sandstone, siltstone, mudstone, and shales. The depositional environment for this formation is fluvial channel. The third location is Hulu Setiu. It has only single outcrop and comprised of interbedded sandstone and shale deposited in lake environment. There are 2 main outcrops in Pantai Kemasik, which is the first outcrop is shown in the left figure and the second outcrop is shown in the right figure. These 2 outcrops are mainly composed of mudstone and sandstone. Both of them was formed from lower Carboniferous age. The first outcrop that is shown in the left part is overturned, thus the setlog is started from the highest part to the lowest part, while the second outcrop it follows the principle of original horizontality and principle of superposition, which means that the older rock layer is laid at the lower part and the younger rock layer is laid at the upper part. In these 2 outcrops, joint and fault can be shown clearly as shown in this slide. As we know, joint is the fracture of rocks on the surface with little or no displacement. Fault is the fractures in the bedrock along the tectonic movement. In this slide, the litholock is shown clearly. The left outcrop has a more complex setlog compared to the right outcrop. As we can see in the slide, these 2 outcrops are mainly composed by mudstone and sandstone. Due to its tidal depositional environment, the tidal features can be found in both of these outcrops. Other features such as herringbone, heterolithic bedding such as wavy that was formed by interbedded sandstone, and mudstone can also be found in the first outcrop. Besides, there are also ripple marks and cross bedding that can be found. The swelly and hummocky cannot be found here since they are not the tidal features.
Next, our second study area is in Bukit Keluang, Besut, Terengganu. In Bukit Keluang, we come across 2 localities. This is the first locality where it consists of breccia rocks and also some para and auto conglomerate. The class size occurs from boulder to granule. It is established during the late Permian to late Triassic period. The grain size is finding upward and it has tectonic evidence of providing it was a volcanic area. Structurally, few tectonic evidence, particularly rivers and normal faults, commonly observed at these hills. The most complex structures crop out at the south part of the Bukit Keluang. For instance, asymmetrical west plunging faults formed by rivers fault can be found at Bukit Keluang. In second locality, we have come upon 7 spot located along the coast and estuary. The reddish color of the rocks is caused by the presence of high iron oxide. Generally, Bukit Keluang exposed encompasses massive conglomerate which gradually changes to interbedded of conglomerate and sandstone in the younger section with varying depth of 30° to 40° orientated to the southwest. The age interpretation was assumed based on the lithologies and depositional environment. The first outcrop setlog of first locality of Bukit Keluang consists of mainly conglomerate which interbedded with sandstone. It have some sedimentary structures occurs at sandstone such as ripple laminae, cross lamination, plana cross bedding and tuff cross bedding. The second outcrop setlog of first locality of Bukit Keluang consists of mainly conglomerate which interbedded with sandstone. The setlog of second locality of spot 1 shows it mainly consists of conglomerate with gravel lithology where the class size is pebble. The setlog of second locality of spot 2 shows it mainly consists of conglomerate with lithology gravel where the class size is pebble. The setlog of second locality of spot 3 shows it mainly consists of conglomerate with gravel lithology where the grain size is ranged from medium to pebble. This spot also consists rounded sandstone with para-conglomerate laminae. The para-conglomerate is composed of cylinder conglomerate, angular conglomerate and granite. This locality mainly have interbedded of para-conglomerate and auto-conglomerate. The setlog of this spot shows it consists of conglomerate interbedded with sandstone. The grain size for sandstone is medium and for conglomerate is pebble. The setlog of this spot shows it consists of conglomerate overlain by shale. The class size for shale is clay and for conglomerate is from granules to pebbles. Spot 6 of second locality setlog shows it mainly consists sand to gravel lithology. The class size is from medium to pebble. The conglomerate have interbedded with sandstone and shale to have clay lithology. The setlog of spot 7 consists of tufaceous sandstone that are finding upward sequences.
Last but not least, the Bukit Hulu Setio in Terengganu. So there are one outcrop that we measure for the sedimentary rock logging. The first one site is consists of sandstone, shale and conglomerate clastic sedimentary rock with interrupt by the fault zone. As you can see, the fault become larger in the gap because of the erosional over time. The groundwater and rainwater flow through the gap, which is contribute the more critical erosion. The second site is consists of pyroclastic sedimentary rock such as tufaces, which is located beside it. The sediment rock at Hulu Setio consists of shale, sandstone, conglomerate, and pyroclastic tufaces. The grain size of sandstone is fine, meanwhile the shale is thick grain size. For the turf, the range grain size from the fine to the coarse grain size. As the total you can see, they are interbedded shale with fine sandstone in the range approximately 1.5 cm with total 30 cm in thickness. Next, the interbedded shale with fine sandstone with range 5 cm to 15 cm, about 45 total in thickness. There is about 342 cm in thickness of conglomerate with grain size from fine to the coarse. Lastly, the tufaces sedimentary rock has 200 to 127.5 cm in thickness for the fine to the coarse grain size distribution.
Next, we will present the lithostratigraphic correlation between these three outcrops. The interbedded mudstone with sandstone bedding are related with both localities. This is because both localities have correlation between each other. Even though the lithology is in the same formation, it has slightly different thickness due to compaction or erosion. The secondary structure from both localities probably indicate the same depositional environment, such as wavy heterolithic bedding. This is because both localities probably have been influenced by same tidal current, which produced the same percentage of mud ripples on sand. This correlation is based on two outcrops located at two different places. One is located in Hulu Setiu while the other one is located in Bukit Keluang. During fieldwork, there was tuff in the outcrop at Hulu Setiu. The same tuff was found at Bukit Keluang. Although having a different depositional environment, the presence of tuff indicates that both outcrops were influenced by the volcanic activities. Presence of conglomerates with similar characteristics also suggests that these outcrops are lithologically related. However, there were no fossils found to prove that these two outcrops formed at the same time. Since Bukit Keluang is a fluvial environment and Hulu Setiu is lake environment, we can give a vague conclusion based on speculation that the fluvial sediment carried from Bukit Keluang had deposited at Hulu Setiu million years ago. However, this mere speculation needs to be clarified further by conducting deep observation on these two outcrops.
In a nutshell, there are three localities that indicate different type of depositional environment in Terengganu. From all localities such as Pantai Kemasik, Hulu Setiu and Bukit Keluang show different lithologies and paleocurrent secondary structure and geometry as parameter to interpret the depositional setting. For example, Pantai Kemasik locality is influenced by tidal current, Hulu Setiu, and Bukit Keluang is influenced by fluvial environment like lake and estuary. By the sedimentary logging method, we can interpret the depositional environment by depositional parameter. Thus, parameter of Kemasik probably in a deep marine area, and Hulu Setiu and Bukit Keluang are quite related in a fluvial area from the lake to the coastal area like beach.